to fence an area of 37.5 million square feet in the rectangular field. So read this question carefully. So we have a rectangular field divided into two equal parts. Question is, what should be the length of the sides of the rectangular field, means x and y. So let x and y be the dimensions of the field, and the area, total area, should be 37.5 million square feet. So this is tricky because of million. That means we got 6 zeros after this. So 0.5 means 375 and 5 zeros square feet. That's the constraint. So I want to leave million for now and I'll come back to that later. So x times y is 37.5. Now divide by x to isolate y. So y is 37.5 all over x. Later, as soon as we find the value of x, come back here and find y. Now we need to minimize the cost of the fence. That means the fencing is here, x, 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 y, and y. Okay, if the fencing, the length of the fencing is minimum, that means the cost will be minimum. So we can say cost function c, or you can write f, that is 3x, this is y, and y, 2y. Replace y from the constraint to write the cost function in terms of one variable. That is 3x plus 2 times y is 37.5 over x. That is 3x plus, if we multiply, 75 over x, this one. Now we want to minimize this function. Okay, to maximize or minimize, we need to find critical numbers. We first find the derivative. Derivative is, derivative of 3x is 3, and number over x, okay, is the quotient. You can use quotient rule, and derivative of 75 over x is negative 75 over x squared. Okay, check, this is the derivative. Now we set derivative 0, that means 3 minus 75 over x squared equals 0. Now we need to solve for x. This is negative, so move this over, add 75. So I'm going to write here, so 3 equals 75 over x squared. Now only one fraction, 3 is 3 over 1. We can cross multiply. Okay, 3x squared equals 75. Divide by 3. That means 25. Take square root. We get 5. Plus minus 5, but x is always positive. It's the length. Okay, x is 5. Now we need to see how x equals 5 minimizes the cost. And if we plug x equals 5 back here in the constraint, we can find value of y. Okay, we can find second derivative, or if we write down the domain, then we can use closed interval test, or we can always do first derivative test, because the x value, this is the length, so it has to start 0, and I don't know, it's a lot, but 5 is here. So we pick a representative from each interval, maybe 1, 6, and we plug that into derivative. Okay, derivative is here. So that is c prime derivative cost, and if we plug in 1, 3 minus 75, it will be negative. So c prime is negative, means the cost c, the curve c, this is negative, means first derivative is decreasing. If we plug in 6 here, 3 minus 75 divided by 6 squared, it will be a positive number. That means c prime derivative positive means the curve is increasing. So we got minimum. Okay, So x equals 5 makes C minimum. We got local minimum, but this is the only minimum we have, so absolute minimum. So we have answer here. Thus, the dimensions are, so one of them is 5, but we need to take care of this million. Million means 6 zeros. And here, y is 37.5 over x, so 37.5 over x is 5, 7.5, but this is not correct, so we need to put correct units. We have million square feet, so we need to write in terms of feet. Million means what? How many zeros? 6 zeros. So how about that is, if I give 3 zeros here and 3 zeros here, that's how we get 6 zeros, million. So 5,000 feet. And this one is, so put 3 zeros. That means when we get rid of this, so only 2 zeros. So 5,000 feet by 7,500 feet. Okay, that's the answer. Final.